Hello and welcome to another mini lecture series. So in this video, we are going to take a look at two-dimensional arrays. And before we can actually do that, we need to tackle the idea of one-dimensional arrays. So in this slide, you actually see two arrays, array A and array P. And you might notice something special about array P, which is that the ith element at array P is simply the sum of the elements from the 0th element of the A array till the ith element of the A array. And what do I mean by this? Let me just quickly explain this with an example. So let's say if we take a look at the element at the third index of P, 26, and we notice that 26 is simply the summation of the elements at the 0th index all the way till the third index element in array A, which is 3 plus 5 plus 8 plus 10, which is equal to 26. So we can actually generalize this idea of prefix arrays to allow us to find any one-dimensional range sum in constant time. So what do I mean by this? So let's take a look at a concrete example. So in this case, let's say we want to find some of the elements at the second index all the way till up the sixth index. So in this case, it will be all the way from 8 all the way till 4. And to do this, we can actually make use of our prefix array. So we take 36. So 36 is essentially, So 36 is simply the sum of the elements from 0, index 0, all the way up to index 6, and this actually includes more numbers that we need necessary. So what we do is we subtract off the remaining numbers that we don't need. So in this case, we subtract 8. And we can actually generalize this idea. So let's say if we want to find the sum of elements from the ith index to the jth index, we can actually use this formula. Now let's try to extrapolate the same idea to two-dimensional arrays. So let's say we have this random two-dimensional array and we want to find the sum of the elements from x1, y1 to x2, y2, basically the entire area that is marked out in red color. So just imagine that we have this function sum ij, which essentially allows us to find the sum of the elements from 0, 0 all the way till ij. This is analogous to our prefix arrays in the sense that an element in array P will give us the sum of the elements at the 0th index all the way till the ith index. Okay, so to actually find this red region that I've been talking about, using this sum function, what we're going to do is we're going to do a little bit of a mathematical equation formulation. So first we'll start with sum x2, y2. So sum x2, y2 actually give us the sum of the elements all the way of this entire yellow rectangle, which is more than what we need. So what we do is we actually subtract off the leftmost column first of the region, okay, so that we don't have these extra elements in our calculation. Next, we also subtract off the topmost row, and notice now we're actually getting closer to our final formulation. But there is a problem. The problem is that we actually subtracted the 0, 0 element, okay, basically the element at the top leftmost corner of the array, two-dimensional array. And to rectify this, all we need to do is to simply add it back. And this actually gives us the sum of our elements that we actually desired. So this idea of actually adding all the elements that we need and then subtracting all the elements we don't need, and then finally adding back the elements that we subtracted accidentally, right? This idea is actually inherited from this idea of inclusion-exclusion principle in mathematics. So some of you all might actually recognize this. Now the question now is that how do we build the sum ij function? So recall that the sum ij function is basically the sum of elements, is a function that retrieves the sum of the elements from 0, 0 all the way till some index ij in constant time. So how are we going to build this sum function? Because in order to use this sum function, we first need to build it. Okay, so I'm going to show you how we can actually build this sum ij function using a very simple walkthrough example. So on the left hand side, you actually see an actual array A, and on the right hand side, you see a prefix array P, which is what we're going to be filling up. Just note that Pij, okay, is exactly the same as sum ij, in the sense that both will give the same output. So what I'm talking about is that, let's say this element, okay, this element at array P will essentially give us the sum of the elements of this will give us the sum of 5 plus 10 plus 6 plus 3, because sum ij gives us the sum of the elements from 0, 0 all the way till the ij index. Okay, first off, the base case, the very most basic base case, is that the top leftmost corner, okay, 0, 0, the 0th element, the 0th row and the 0th column of array A is equal to the prefix array P, right? This is a no-brainer. Okay, so there are two base cases that I like to distinguish. So first of which is the top row of P. So we just zoom in onto the top row of P, and we actually notice that the top row of P, if we focus on the top row of P, right, it is exactly the same as building our normal one-dimensional prefix array that we have seen in our first slide. The second base case is basically we can zoom in onto the first column of P when we build the first column of P. So in this case, 5, 6, 15, right? So 5 plus 6 is 11. So this gives us the second element in this column. And finally, 5 plus 6 plus 15 will give us 26, which gives us the last element in the first column of the prefix array P. Now, the tricky part comes here. So let's say we actually want to calculate the element, okay, this green element highlighted in green. And how are we going to do that? First, we are going to include 11, okay, with the red color. We're going to include the element just to the left of the green element, because this 11, this red element will give us the sum of the elements in this column, 5, 6. Next, we also want to include the purple element. The purple element, which is basically the element above 24, will give us the sum of the elements in the top row. Now notice when we include both 11 and 15, we're actually including 5 twice, which is highlighted in blue. So what we need to do in order to correct the recomputation is that we need to subtract it off once. So again, this same idea is presented in the inclusion-exclusion principle. Last but not least, we just need to add the actual element itself, 3. And this will give us 24. And we can actually verify that this answer is correct by adding 5 plus 10 plus 6 plus 3, which will give us 24. So we can actually generalize this same idea, okay, for any other element that is not in the first column or in the first row of the prefix array P. If it's any other cell in the prefix array P, we can actually use this formula to recompute the resultant sum. Okay, so now I want you to try as an exercise on your own to actually try to fill up the remaining cells in the prefix array P using this formula. Try to get an intuition behind this mathematical equation. Okay, so after you have done, you should have gotten this as your answers. And yep, I think that's basically it for this mini lecture series.